Hello, I am Jodie Azhar, and I'm here to talk to you today about the crossover in video games between creativity and technology and how you can embrace it if you're making games to be a better game creator. Ooh, I found the mouse. Cool. So I'm currently the CEO of Teazelcat Games, which is a studio that I set up at the end of last year. I'm currently directing our first unannounced game, which is a narrative exploration title. But I've been working in the industry for over 10 years now, and I've worked on 10 shipped PC and console games and a couple of mobile games. But I didn't know I wanted to be a game developer until I was actually at university. For some reason, it hadn't occurred to me that people make video games and that I could do it for a career. So when I realized that actually I had this interest in science, maths and art, and video games was this perfect sort of combination where I could bring all those passions together and make something that potentially millions of people will play and interact with. So I started off in the games industry as an animator, animating characters that you see in video games, making them move. But I realized in my first job that actually my interest and skill in the technical side actually made me a much better developer, because I could talk with programmers and solve problems. So when we were working out the animation system, how to get characters to move from point A to point B, and how to get their animation blending smoothly. So when characters are stood around looking like they're breathing and have to go into suddenly I'm walking, to make that look realistic and not like you've got two bits of data that are having to interpolate, which is what happens in the background. You're blending from one pose to another, but as a human being, we just naturally sort of move, and we'll move our arms and legs into whatever the next natural pose is. But when you're creating a game, you have to, as an animator, set all those individual poses, and you don't know if the player is going to move left next, right next, going to start running. So because I was interested in programming and science, I could work with other people to go, right, how do we make this look really awesome? And working with programmers and other artists, I found out that there was this job role called technical artist, which is pretty much exactly what it sounds like. It takes the technical skills such as programming and artistic skills, knowing how to model, how to animate, how to make things look really good, and combines that into one role where you're sort of doing little bits and pieces of everything. But it's not just technical artists who bring technical and creative skills together. Video games are this awesome interactive medium where there are different challenges, and if each different type of game has different challenges. So something like these big AAA experiences where you're trying to make really realistic graphics, you've got all these technical constraints of, right, how do I fill it with all this detail and make it look lush and alive while the game's still got to run smoothly so that players don't get lag and they're still enjoying the game. You could have technical challenges like how to get a game to work on specific hardware. So games on your mobile phone, you've got to work out, right, how do people interact with that? How do we present the information here in a really visual, fun way, but make it easy for people to understand what they're supposed to do, how they're supposed to play the game? And creativity isn't just about visuals. It covers audio, design, even programming is really creative because you're solving things in different ways. any part of development where you're not just concerned about the functionality, but you're thinking about things in an imaginative way or coming up with new ideas, it's all creative. So there are audio games, there's text adventures, where you're still having to marry technology and creativity together so that you're making a fun experience for players. And if you fail to do that, then you could have a beautiful or original game that just suddenly feels like it's an art piece. If there's gameplay bugs or features don't work intuitively, then players will become frustrated. And if you have a really clever idea for a game, but it's not engaging, or you come up with a game that's completely unoriginal and it looks like a game people have already played before, then players are gonna sort of drop their attention from it because they're like, well, this is the similar experience that I've already had. So you kind of need both the functionality and creativity to make something that's fun and players want to play. So because of my background as a technical artist, a lot of the examples will relate to the visual side and how that works with programming. But the ideas can be applied to design, to audio, any way that you can sort of take your creative skills and technical skills and try to use them to make better games. So with technology and creativity being so closely intertwined, it can feel a bit frustrating when job roles seem really specific and it feels that different departments have different goals. So sometimes it feels like other people just don't understand you, or they don't understand what you do, or that they don't value your work. But each department might have their own individual objectives, such as the code team might need to get stuff working so the game actually runs correctly. Artists might be concerned with, right, we've got to make this really beautiful so that people love looking at our game. And design might be thinking, right, we need to balance the game so that it is fun, it doesn't feel too difficult, it doesn't feel too easy. But everybody wants to do a good job, because everybody wants to make an amazing game. They want their part of the project to be really good and finished to a high quality so that people have a good experience. So regardless of how each individual or their small team contributes to the project, there's this common ground of everyone wants to make an awesome game. And these days it's easier than ever to just start making a game by yourself. So there are game engines or bits of software that you can download at home. Engines such as Game Maker, Unity, Unreal, that you could just sit at home and start learning, how do I make games? But despite that, commercial games that you sort of buy in a shop, very few of them are made by just one person. It takes a whole team of people with different skills to make your favorite video games. And creativity is a lot better when you have different people, because everyone has different experiences, they've all got different ideas, and when you're challenging each other's ideas, then you tend to come up with things that are new and unique. So the larger the game that you're making, the more specialized the skills are that are required. On smaller teams, you're probably going to work a lot closer with other departments, because you just need to get more done, and there's more opportunities to just use different skills. That doesn't mean that there aren't those opportunities if you're working in a larger team, but you might have to work out when it's appropriate to try and do something outside of your job role. So if you're an artist, go, right, okay, I want to try and solve these problems technically in order to make my work better. Something that I find really frustrating is when you're at school and it's really difficult for teachers to know every single job role that there is. So teachers won't know exactly what it takes to be a game developer, what it takes to be a game artist, to be a game programmer, to be an audio designer. And sometimes you get conflicting information that actually, if you want to go the science route, that you can't choose art, or that you're not good at it. And if you want to be an artist, then you're probably not going to enjoy maths or science. Actually, having both of these skills works really well together in game development. Your first job in the industry, you will probably be doing a specialized role, such as just doing art or just doing programming, because you need to do at least one thing really well, that you can finish something to a high quality to put in the finished game. Projects don't have the luxury of people just being able to do whatever they find fun and interesting. But there is opportunity to use your skills to come up with new solutions and make things really awesome. And just because it's not part of your job doesn't mean that you're unskilled in other areas. So it can feel frustrating when people think that they're bad at something because they've put off trying it. Maybe you haven't had time to explore a certain avenue because you've had to make decisions like, what GCSEs do I do? Or there's a university course that I'm thinking of doing, and for that I need to focus on science, or maybe I'm going to go down the art route, and you just haven't had time to explore another area. But you don't have to be a master of a skill in order for it to be useful. And game development is this perfect example of where people who've got a passion for creativity and technology can thrive. Because skills and job roles sit on a spectrum. It's not just, you're an artist, you only do art, that's your focus, or you're a programmer, all you have to think about is code. Because at the end of the day, you're making a video game, and that's something that people see and they interact with. And artists and programmers have got to work together to come up with something that players can play. So it's still okay if you want to just be an artist and just make beautiful things, and it's totally okay if you just care about, I want to write really amazing code. But some people will naturally kind of want to be somewhere in the middle. So if you want to focus on making art, but you think a little bit technically, or you're a programmer, but you're very creative and you want to make something a bit more visual. And then there's this area in between called technical art. So it sort of sits between programming and art, and different technical artists will be more artistic or they'll be more technical. But as a technical artist, you don't just write code and you don't just make art. You solve problems. So as a technical artist, you might be thinking about the way to reach a desired look in the game. So the artist might decide, right, we want this to be a cartoony game. Our inspirations are Mario, Sonic the Hedgehog. We want to use that kind of stylized look. But at the minute, we're making games that look really realistic. So they'll work with technical artists to decide how that should work, and work with the programming teams to implement it on the game side. There are other technical roles, such as technical design, and there's a talk tomorrow by Jess Hyder at 1 p.m. about the role of a technical designer. Again, it's a similar role where it sits between these two disciplines that might seem quite disparate to begin with, but actually there's this beautiful overlap where you're solving problems and you're making things that are useful for artists to help make games amazing, or you're helping other designers to create a really good, fun experience. So what is a technical artist? It covers many different things. Sometimes they write shaders, which describe how something should look. It's a bit like a mathematical function to describe the way something is rendered on screen. So we use shaders to create things to look like water, to make it look like they're made out of fire. Sometimes we'll use them to create sort of magic effects. For me, it's really exciting because I get to use maths to make stuff that looks really cool on screen. They also make tools for artists to use. So it might make an artist's workflow a lot simpler and speed up their process. And a technical artist's key skills are being a problem solver, understanding art processes, knowing a programming or scripting language, and having good team working skills. But these are all really valuable skills for any developer. You don't just have to be a technical artist to try and develop these. So it's definitely worth sort of being comfortable working with other people if you want to make video games and trying to understand your own processes as a developer. Yeah, but the main difference for a technical artist is their entire job is about solving problems. But despite technical art covering quite this big range in the middle here, you tend to still find that on projects there's a lot of artists and a lot of programmers, and really not that many technical artists. And that tends to be because when you're working on a game, especially like a big game like this, there's a lot of content that needs to go in. So you need artists to be making all of these buildings, every single box, every character, every weapon, every vehicle, every single tree. And if you've got different areas of the game, you've got all these different interesting, visually looking things that all need to kind of feel unique. And the more different detail you have, the more it feels realistic, rather than feeling like a computer program where you're seeing the same building over and over again. And that takes a lot of people. So you need a lot of artists to make big games. And you also need quite a lot of programmers, because they cover a lot of different areas, such as how to render this, how to implement the gameplay. So any mechanics or anything that is kind of unique to your video game, a programmer is behind the scenes making it all work. Yeah, it needs video games are a very technical area, so there's a lot of programmers behind the scenes making everything run. But while you might not have so many technical artists, your art team and your programming team will still be working together to solve problems themselves with the help of technical artists to decide what is the most appropriate way to solve those problems. So even if you're an artist who just cares about art, you still need to appreciate that there are technical constraints. You can't drop tens of millions of individual leaves into a video game and expect it to render, because the game has to calculate where each of those leaves is, how to draw them. So the less there is on screen, the faster your game will run by default. But once you start filling it with content, then things will slow down, as it has to do a lot of calculations. So as an artist, you still have to be aware of how the video game works, what's running in the background. And as programmers, you need to understand what the artistic vision is for the project in order to make sure that you're hitting those targets, and you're making systems that work with the game and what the artists and designers want the game to be. So depending, say, on the length of a character's arm, that would change where they're going to be interacting with objects. So to open a door, if I suddenly change my character from an adult to a child, you're suddenly going to have a different arm length. You're going to have a challenge of, am I reaching up to pick something up, or as an adult, am I reaching down? So they need to understand what art is in the game to make sure it works correctly. Now we have developers there's no perfect shape to what you should look like, whether you should be focused on your core discipline. So as an artist, you should go, I want to be an expert and I'm going to learn all the skills to be an amazing artist and that's going to be my core focus. Or whether I want to be an all-round good developer, so I want to know a little bit of each area. There's also different things that motivate all of us. Some of us might enjoy being innovative, so coming up with new ideas or putting new things into the game. We might be motivated by getting work done, so finished and completed. We're not too worried about is it new, just as long as it's in the game, it's working and people can play it. Some people are good leaders and some people like just being given a job and that they can do really, really well. So there's nobody can tell you, right, this is the path you should take to be a game developer and these are the exact skills that you should develop. But one phrase you might hear is T-shaped developers. So that's the idea that you have a strong, deep understanding of your area. So you could be a really good programmer and know a lot about programming, but you've also got a breadth of knowledge across different disciplines. So you've got an idea about different areas. To start off with, you might just want to focus on expanding your knowledge a little bit outside of what you're interested in. So you could be a character artist, makes amazing character models, but also knows a little bit about how to make environment art, so buildings, trees, the terrain. Maybe they know a little bit about animation because the characters need to be animated. So they know a little bit about the animator's work so that they can make more appropriate models. But it can be, the breadth of your knowledge can be a lot wider. So you could be focused on design, but you know some programming, you can create scripts, you know a little bit about animation systems. Anything that you understand outside of your specialization area will help you be a better developer because you can talk to other people better. And you can share ideas and knowledge. So whatever area you are interested in, communication is a really important part of working in a team. Often problems arise when people assume each other's intentions or just kind of misunderstand what someone wants because your focus is different. But it's important to remember that it's people that make video games. So when you're talking between different departments, to understand that everyone still wants to make this amazing game experience and that there's a reason why people do things a certain way. So take our artist and programmer friends, for example. Perhaps the programmers made an update to the game to make it run faster, but it meant that it broke some of the trees in the game and they look really weird. So when the artist goes into game and they see that their work's all broken, they automatically think, oh, the programmers just haven't taken our work into consideration. They've just done this update and nobody told us because they just don't care about our work. In fact, it probably turns out that in between the programmers writing an update, one of the artists made some new trees and put them into game, but they didn't have the new updated version of the game. All of this is miscommunication because the programmers thought that they'd updated everything all at once. So there's no need to tell the artists because they'll just get on with their job. And the artists have just assumed that the programmers don't care because they've come to the game and gone, why is all my work broken? But once they start communicating, then they realize what's gone wrong and can fix it. But it's actually a lot easier to just involve everyone to begin with. Talk to people, and different people will know certain things that you don't. So you can find potential issues before they actually become problems. And the fastest way to learn is to ask questions. Learn what other people do, how that fits into the big picture of the game. You can ask your team leader why things are done a particular way. You can ask them how to do new things. There are forums on the internet where you can ask all crazy questions about how different software works. Learning more about how things work and how they fit together makes you more informed, and you can make better decisions about your own work. And learning things is really great, but there can be downsides. You don't want to continually be bothering someone by always constantly asking questions so that somebody else can't get on and do their work. But you also don't want to be chasing an idea down the rabbit hole and you realize 2 hours later that you could have found the answer by just asking someone or posting on a forum and someone's immediately got the answer. So there's this 15-minute rule where you spend 15 minutes trying to solve a problem any way that you can think possible, and then you ask for help. And now this is really good because it helps you develop your own problem-solving skills. You have first-hand experience of going and looking for the answer yourself or trying things that you might not otherwise sort of find different solutions if you just ask someone. But it means that you're not wasting time by going, I'll find it eventually, just like 2 minutes more, 2 minutes more. And sometimes you're not the best person to solve a problem. It might be that you don't have a little piece of knowledge that someone who's sitting right next to you has, and you can just ask them. But don't let fear stop you. Often when we think we lack a skill in an area, it stops us from trying it. We don't like to look stupid. And I've often heard people say, oh, I can't draw. When anyone can pick up a pencil, you can put some marks on paper. You don't have to be amazing at drawing, but you can draw. Or people will be, oh, programming's too complicated for me, like I'll never understand it. And they've never tried it. A lot of programming, sort of the basic fundamentals, are quite simple to get your head around. It's all kind of logic of, if I do one thing, something else happens. And it's quite easy to get something on screen that you can see, oh, if I press this button, I make an explosion. And that's really cool. And you get this great reward of, I made an explosion happen. But there's this fear of the unknown, or a worry that we'll do something wrong that stops us from learning new software. We can put ourselves off learning things by convincing ourselves that we won't understand it, or it's too complicated, or I don't have time to learn, it'll take too long. But it's really important to be inquisitive and try things, give it a go. It might turn out that actually, no, I'm just not interested in that area. But until you've given something a chance, you never know. It could turn out to be sort of like, that's the area that I've grown to love. And you wouldn't know otherwise. This is an example of when I worked with artists who are scared of using a particular piece of software. This is called Perforce. It's called source control software. So basically when you're working on a big project, there's lots of files. You might be working on a game for 6 months, maybe 3 years. And in that time, you'll make lots of different assets that all need to be stored. You need to back up your files. You need to control who's got access to each file. So only one person at a time might be able to be editing a certain part of the game so that you're not constantly overwriting each other's work. So I worked with 2 different teams of artists, and both these teams had to use Perforce to back up their files every single day whenever you finished some work or it was at a particular point. So one team of artists, whenever they had a new member of the team join, they would be introduced to this software as part of their job. It was a step in their process. And if you look at it, it's really not a great looking piece of software. If you're an artist who loves visuals, you're like, that's a lot of text and things that I could press and make a mistake. But when they had a new member of the team, they were told how to submit their work, how to get new versions of the data, and explain to them what this software was and why it was important to them and why it needed to be part of the process. So every single artist learned how to use it, and they'd use it on a daily basis. Absolutely fine. Another team of artists I worked with, whenever they had a new member of the team, the first thing they do would explain the art processes, how to make the art itself, and how to finish something from the very start. So you're given a piece of concept art, and you've got to make a model of what's on this piece of paper. And only when they'd finished a piece of work were they then introduced to this piece of software. It might seem like a small difference of when you get introduced, but it changed their mindset. Because they were introduced at the end of the process of, you've done the important thing, you've made the art, they saw submitting their art and making a backup as an extra step that kind of ended up feeling a bit unnecessary, because it's like, this isn't making art and I don't really get it. So the artists in the second example were a lot more reticent to use this, and that increased the likelihood of them using. It increased the likelihood of them losing work because they weren't making regular backups. Because they weren't being explained what the software was, they were scared of accidentally doing something wrong, and they didn't investigate sort of how to use the software themselves. And they kind of felt like, oh, because I'm an artist, I don't know how to use it because this is technical, and that's not my area. But obviously, if you take the two examples and go, I've got one team and they're using it on a daily basis and they're perfectly fine and happy, they might not know sort of the advanced features of it, but they're getting on fine. And you've got this other team that are like, no, it's definitely not that one group of people is more intelligent than the other. It's just that one of them is scared of using it because they might do something wrong, they might delete files, and it meant they were misusing this software, and that caused problems for other teams that didn't know where to find art files, or didn't know which files were up to date. Likewise, for anyone who's unfamiliar with 3D asset creation, 3D software can seem really daunting. So this is a piece of software that many artists use on a daily basis. If you look at all the different buttons and menus, then it's quite clear that artists aren't stupid. They're very intelligent people who can handle a lot of data and a lot of buttons and a lot of different things going on. They're not completely untechnical. They have to use technical software in order to do their job. But for a programmer who doesn't have to interact with this, if you just open it up, it's like, how do I do an even simple thing like I want to make a cube? You've got to go and search around and find that, and you might just be like, oh, I'll never need to use this bit of software, it's not part of my job, there's no use for this for me. But actually something simple like navigating in 3D space can inform programmers of what the artistic process is and how artists think. It's especially useful if, as a programmer, you have to make tools that artists will use, because you can understand what they're familiar with, and then if you're making similar tools, it's a lot easier for people to switch between one program and another that are very similar in their terms of interaction. We kind of don't think about it, but like every single bit of software, if you're using Windows, has got the close button on the top right, you've got your file menu over there. When people can expect those things, then it's a lot faster to do their job. But it's also really useful to learn basic functionality of 3D software as a more technical person, because it means that you can make simple bits of 3D geometry that you might need to use to test a new feature that you're working on, or prototype ideas without having to sort of take up artist time. You can create your own data to sort of make something new. And it's also useful for programmers and designers if they want to block out the approximate size and shape of things. So you can make a working game that people can play with just cubes that might not look really exciting, but you can get something that works before you pass it on to an artist and go, right, this is the size of all my buildings, now you go and make it look really beautiful. Something that doesn't seem particularly technical is reading error messages, but it's something that's really easy to just close. So a lot of people tend to do this, but there's generally quite useful information in an error message that will tell you maybe what's happened or how to solve it. So rather than just going like, oh, click yes or no, or oh, you can find, oh, it's made a recovery file, I can get my data back, or it might tell you what was going on when the crash happened. And what's then useful is you can Google it. If there's an error, you can just copy the error into Google, and a lot of the time other people have had exactly the same problem. But there's a lot of other things. It seems really untechnical to say just Google it, but you can often overlook the simplicity of just going, I want to know how to do something, I'm just going to type it into a search engine, rather than, right, okay, I need to go and ask another person on my team, like, how do I solve this? A lot of the time there are tutorials or explanations on Google that you can learn how to solve a problem or even how to make a game. And there's more effective ways of using search engines that some people aren't aware of. There are these things called search engine operators that are really simple to just narrow down the amount of data, the amount of search results that you get back that might not be relevant. So I want to search for frogs, but I don't want results that include toads in it. So if you put a hyphen at the beginning of the word, it will exclude that. So I'll just get returned search results that are about frogs, but not about toads. One I constantly use, which is absolutely brilliant for if you're searching for people's names. So, I don't know, Keira Knightley. If you put that in quotation marks, it will search for those two words together rather than just, here's a load of search results about Keira or Knightley, or green and frogs. We're only looking for green frogs together. And you can also search within a website. So a lot of the time a search engine will just send you back like the top result from a website or what it thinks is the most relevant. But if I just want to look for things inside frogs.com, then you can use the site keyword and you will search within and it will return a lot more web pages just inside that domain. And as a developer, I rely on Google a lot. So it's really not cheating because I don't have to memorize lots and lots of facts and I don't need to memorize formula. I can literally go in and it even gives me a graph. So I can go, oh, this is what sine wave looks like between 1 and however big. And I don't have to keep loads of books on different programming languages or have to constantly remember, like, okay, this is what happens if I'm doing this task or that. It's not a cheat. It just saves you from having to memorize lots and lots of information off by heart that you'll use once a year. So Google or any other search engine, really good friend. Simple scripting. So if you are an artist, there are a lot of art softwares that have a scripting interface that allow you to just do simple tasks a lot of the time through a script rather than manually having to press lots of menu buttons. Even the simplest scripts can do useful things. So the top example, if I've got a scene that's got 5,000 objects in it, and I just want to find all the objects that are called horse, I can use a list command and it will return back. It'll give me a list of everything whose name starts with horse. In the second example, we've got a simple for loop. So it will go through, I've given it a list of strings, these words, horse, frog, and duck. And I want to find every object in my scene whose name starts with horse, frog, or duck. And that can be really useful if I get halfway through a project and we go, we don't have horse, frogs, and ducks anymore. Everything is now just a horse. Or it's a pig, and I need to rename everything to pig. I can write these 4 simple lines. It will return back exactly the data I want out of my 5,000 different unique objects. I can quickly rename those. Just a lot easier than manually selecting in a piece of software the possibly 3,000 objects. Or you can do something like moving something in space. If you wanted to build a fence, you've made a single fence panel, and you want to place 100 fence panels, 100 units apart from each other. Again, we've got this simple for loop that we're working on all the selected objects, and we're just placing them 100 units apart. The logic behind this, any artist can understand, but it will save a lot more time than manually having to move an object across 100 units each time, and you're a lot less likely to make errors by accidentally nudging something or only moving it 99 units. So it'll save you time and you won't go insane just your job turning into moving things around rather than making things look really cool and beautiful. Because creating content for games can be a complex process. When you've got technology constantly changing, there often tends to be a lot of steps to get your beautiful piece of art into the game engine and ready and set up so people can see it. So often there's ways of improving these processes through automation. Once we've worked out what we need to do, you can usually write a script that does tasks in order. So like with the script to place 100 objects, place all the objects 100 units apart, rather than doing that step over and over again, we create a tool that a user just presses a button and it does it for them. And there's loads of tasks that we could use automation for. Resizing textures, exporting assets to the correct location, tagging game assets in the game engine. And it might seem like a really technical task to automate things, to write the code to do that. But it's important to appreciate it and understand who'll be using your automation tools. So if we've just got a process where somebody's clicking 5 buttons in a row for every single object that they're exporting, it's very easy to go, right, that's a process where I write a script that just emulates me pressing these 5 buttons in the right order, and I can run that on 100 objects, I can run it on 1,000 objects. But when you have more complex ideas, then there might be simpler ways of conveying that information that just makes more sense to artists. So using imagery is a lot easier most of the time than reading words, and it takes up a lot less space. So you can read a simple icon at a glance, it fits neatly into an interface, and then you can do other things with the interface that make sense to people using it, such as making larger buttons that indicate, oh, this button is much more important because it's bigger, because you can build them in a uniform size. And your icon images don't need to be fancy. So if you're a programmer writing a tool that artists are going to use, you can be a little bit creative, or you can kind of stick to like, what's the most basic bit of visual information to describe what this button does. So it's just like playing Pictionary. All the icon needs to do is give a really simple explanation that someone can go, right, that button at the top moves stuff, the button in the middle rotates stuff, and the button at the bottom, I'm scaling things up and down. And even if you don't feel that you've got the technical skills to write automation tools, it's important to observe your own processes so that you're aware that at times when you've kind of got used to pressing those 5 buttons in order, so that you can go and tell maybe a programmer or a technical artist, hey, I keep doing this same process for every single object I'm making, and it's just taking a lot of time. So if you could write a script or make me a tool that does that, it will save me a lot of time, and then I can do my fun job of making the game look awesome. So it's important to kind of not get too used to, okay, it's a boring job, but I know how to do it. And be a little bit critical of, right, is there an easier way for this to happen? Between programming and art, there are all these areas that they are both creative and they are both technical. These are different areas that have a visual result on screen that if you are a visual person and you want to focus on the art side, you can be an animator and just concentrate on making beautiful movement. But if you're an animator who also has that interest in the technical side, then actually things moving through space is all controlled by maths in the background. You never need to touch that. Well, you scratch the surface a little bit because you understand things are rotating, but you never need to do complex maths to be a good animator. You just need to be focused on weighting and timing. VFX, making really cool effects. It could be dust particles, explosions, magic. What the player will always see is what's on screen, what looks visually beautiful, but a lot of what drives VFX are particle systems, programming systems that can, again, be quite mathematically complex. And if you have an interest in that sort of more technical side, you can be a lot more useful by understanding how your creativity and technology makes up what people see in game, and be a lot more useful by thinking about the limitations in the game for rendering, or how to use maths or technology to actually make something visually more interesting. On the programming side, if you are a creative programmer, these are areas that you can explore that allow you to make something really visual and creative that players will see. So there's a lot, pretty much everything that you see on screen, it's had to be touched by programmers and artists, and they all had to work together. So if you are interested in both sides, there's lots of things that you can create that explore that. And even programming that doesn't have a visual result, you can still be really creative about it because there's multiple ways of solving the same problem. And that's where your creativity as a technical person, as a technical coder, as a creative coder comes in, because you can explore different ways of solving a problem and work out what's the most appropriate for the game that you're making, and also for the people who are going to be using your tools or creating art with anything that you write. But just because we've developed different skills outside of our core job role doesn't mean that we get to work on just anything that we want. There's still a responsibility that you've got a job to complete if you're making a game and that's got to be released. So you still have to be aware of how your job fits into the bigger picture and make sure that you're not sort of getting carried away going, oh, I want to solve every single problem. You're still going to have deadlines that, okay, if I'm an artist and I've still got a bunch of characters that I need to complete, you've got a deadline for that, and sometimes it's important to just get on with the job. You know how to make these characters in sort of the way that people have done it over and over again. We'll stick to that, and when I've got a bit more time, I'll solve some of the problems. But thinking about your work in both a creative and technical way helps you to identify ways to improve the final game. It also helps you to identify where to improve the efficiency of how to create the work, so that you're not just spending your time doing the same process over and over again, but you can actually optimize it. There'll be times when you don't have the flexibility to explore different ideas, but those skills will still be there for when you have the opportunity to explore it. So the ability to see where making changes will improve something is extremely valuable. But you also have to be aware that the person who needs to make changes should be the person who's responsible for that area. So while you might have an interest as an artist in programming, you're not going to be changing game code, because if you accidentally do anything wrong, it's going to be the programming team who are going to have to fix it. They're the ones who need to know what's going into the code. Similarly, you wouldn't expect a programmer to see, oh, something is a little bit off with a piece of art, and just jump in and fix it, because there might be a reason why things are set up a particular way. You might accidentally break something by trying to fix another thing. And ultimately, whoever is responsible for that work has got a lot of pride, and they can realize their own vision of what they want that area of the game to be like. So you can't sort of go and change stuff just whenever you feel like it, because you yourself will have a lot of success having your work in the end of the game and going, right, this is my area, and I get to feel really proud of it. So embrace your creative and technical sides. Making video games is a challenge of both creativity and technology. Whether you love making visuals or creating functional systems, your ability to understand both areas helps you to develop games autonomously. It helps you if you want to make games by yourself. You will grow. If you don't have the opportunity to explore different areas in a job, you can make games in your own time, even if they're really tiny little games. Just going through the process of going through somebody else's job area and going, oh, okay, that's what they do, gives you a real appreciation for that area and makes you a much better developer. And it helps you to work more effectively as a team. Communicate with other people to learn new things, and always be inquisitive, but keep the goal in mind. You're making a game. You want to do a good job and make the best game and complete features to a high standard. So don't get carried away too much going, I have to explore every single area and be good at absolutely everything. If you can finish a game, that's way more important than having every single thing perfect. And you've got to work as a team. So share ideas with each other, trust other people to be able to do their job well, and understand what they do, but at the very least appreciate that every role is vital in bringing a game together. So, any questions? Yeah.
Is technical art something that unis like train for specifically? Can you do a degree in it, or do you kind of have to bring things together?
There's a couple of courses that specialize in technical art, but it's still something that most technical artists have got a background in either programming or art, because it's quite a niche area. Like even people who like art or like programming tend to have a bigger interest in one area. So they tend to, I want to go to university, or I want to study a course in programming or in art. And then they sort of find along the way, I'm actually interested in that other side, and they slowly grow their skills. So a lot of technical artists will have started from one side of the spectrum and slowly gone into the middle. So not having studied it won't stop you if at a later date you're like, that actually sounds really interesting, or you get a job and you're like, actually I kind of want to do a bit more of this and move into the middle a bit more. Yeah, I think sort of, yeah, the main thing is having that understanding of how art is made, and then learning scripting or a programming language to sort of help you bridge that gap. But yeah, you can definitely learn those skills later. Yeah.
Hey, thank you for the 15-minute rule and T-shirt developers. That's quite interesting. But the question I have was the slide about observing your own processes. Mm-hmm. Are there any tools or anything you're doing to kind of like help you identify those moments of things that can be automated? Is there anything better than sort of waiting for a process to annoy you before you automate it?
Yeah.
I don't know. Is there a way of sort of capturing?
I don't know for yourself. I mean, unless you're the kind of person who loves keeping spreadsheets of like, this is what I was working on today, and then you suddenly realise.
Is that something you do?
No, I mean, I think that's. I mean, I love spreadsheets, but I think even that's a little bit too micromanagey for me. Like, but like you said, it's kind of the easiest thing to sort of not realise that you're annoyed by something, and you do kind of get used to it and don't realise. If you do work on a team, one of the things is to observe other people doing your job, or if you are a technical artist, it's really good to observe what the artists are doing, because you're usually much more likely to notice when somebody else is doing something sort of repetitive or monotonous and going like, why do you keep pressing those? Like, and if it is a case of it's a process that it might be something that's developed over time where you've added a new feature to the game, so you've had to add a couple more button clicks so it sets stuff up in a particular way, and people just haven't noticed because it's been gradual. Yeah, if you watch other people work, then you tend to kind of pick up when they're doing things that you're like, that looks really boring. Do you not just want to be doing something more creative? But yeah, I think, yeah, for yourself, I guess it's just being aware of when you are doing it, and and not just being like, oh, well, it's only like a couple of minutes now and I don't have to do this again for another like 10 minutes. And being aware of how long it does take you, because sometimes it might just be like, oh, it's a 10-second process, that's fine, I can put up with it. And you haven't actually realized that, oh, I do this 10 times a day, it adds up to like, I'm wasting 10 minutes. Yeah, so it doesn't really answer your question, but yeah, I guess just being a bit critical of not just going, oh, it's fine, I can deal with it.
And like, so I'm just like an independent sort of just doing it as a hobby at the moment. Yeah. But like, if I'm getting involved in game jams and things, it's helpful there as well. It's like, I can help other people speed up them, because it's a time sensitive thing, isn't it? So anything you can do to sort of help move the needle.
Yeah. I think also it's especially if you're working independently, it's weighing up that time of, if you're making a specific game and you know, oh, I'm going to be finished in 6 months and the next game I make might be completely different, it's not worth sort of going, I'm going to write the perfect system that does this one thing, if you know you're going to throw it away afterwards. But it's, if you are going to be doing something for a long time that will save you time, to kind of go, oh, it doesn't have to be the most beautiful tool that is like, if you're just writing it for yourself, it doesn't have to have beautiful icons because you know what the icons do, but it might be like realizing, oh, this takes 5 minutes for me to do, I can write a script because it might take me 10 minutes to write a script, but if I do this task 5 minutes, like every single day, that will overall save me a lot of time. But if you're going, oh, this is a 30-minute process, but you actually only do it once a month, it might not be worth writing a script that would take you 2 days. I don't know if that math adds up. But yeah, there's no point in trying to automate everything if actually you're not doing those processes that often. So yeah, it's just balancing, like, where am I actually going to get the time gain from? Yeah.
Thanks.
Anything else? Cool. Well, thank you for coming.